Well, hello everyone, and welcome back to Math. Thanks for joining me. It's been a little bit since the last video, so I apologize for the delay. I've been a bit busy, but normally what I try and do is every week I try to get about 2 to 3 episodes. This week it's only going to be one, but in any case, let's get going here. So in the last video, we looked at how multiplying and dividing by negatives is actually two actions in one, where the negative part of the negative we're multiplying or dividing by is like a flipping action, and then the remaining part that we multiply and divide by, that's our regular stretching and compressing. So we're going to just get used to that idea today. And keep in mind, this is kind of the last video of the first part of the Fundamentals of Algebra series. So next up, we're going to have the checkpoint. So I hope you've been studying a bit for that. In any case, here are the questions. Try them out now, and we'll get into it. All right, so question 1. Using a number line transformation, calculate the following. We have negative 3 times 2, 1 times negative 3, and negative 3 times negative 3. So ideally, we want to use a single number line transformation in order to calculate all of these. That was part of the advantage of actually transforming the entire number line instead of just doing stuff on it. So if we look, we have A is negative 3 times 2, B is 1 times negative 3, and C is negative 3 times negative 3. So B and C, they both have multiplying by negative 3, great. But A, it looks like we're multiplying by 2, but how can we fix this? Well, we do have negative 3 being multiplied, it's just on the left-hand side right now. But it doesn't matter the order in which we multiply things. So if I rearrange the order like this, which we know is the same thing, then we see clearly, yeah, all of these can be expressed by multiplying our number line by negative 3. So let's go ahead and do that. All right, so what's the first thing involved when multiplying by negative 3? Well, we're multiplying by a negative, so that's going to involve a flip, right? So let's go ahead and do that. All right, so I've flipped it. So now all of the negatives line up with the positives, and all the positives line up with the negatives. So this is our flipped number line. All right, and then we're just going to stretch it out by 3. All right, so I've taken my number line and I've stretched it out to be 3 times long, where all the distance before were 1 tick, but now we have to go 3 ticks over to get from 0 to the next unit. So we are good to go here. So now we can just line things up and see where they land. So for negative 3 times 2, which was the same as 2 times negative 3, we just locate 2 here. And we know overall we multiplied by negative 3 because we flipped and did a stretching. So 2, that lines up with negative 6, which means that 2 times negative 3 had to be negative 6. All right, where's 1? 1 is right here. So 1 times negative 3, that lines up with negative 3. So 1 times negative 3 has to be negative 3. We also know that's true since 1 times anything is itself. All right, now we have negative 3 times negative 3. So this is a negative times a negative here. So we take our negative 3, and that lines up with a positive 9. The reason it lines up with positive 9 is because multiplying by negative 3 involved a flipping, so that means our negative is going to line up with a positive. And it's stretched out our number line, so that's why our 3 lines up with 9, because they've been stretched out to be 3 times as long. All right, good. Let's go into number 2. All right, number 2 says, using a number line transformation, calculate the following. We have 4 divided by negative 2, negative 3 divided by negative 2, and negative 2 divided by negative 2. My black pen was kind of dying, so I've switched to purple, which is somewhat close to black. All right, so we're going to be using a number line to calculate all these. They're all being divided by negative 2, so we simply have to divide our number line by negative 2. All right, so I will take this number line here, and because we're dividing by, well, something with 2 in it, right? I'm starting with everything to be 2 ticks apart from each other, so it's easier when we compress it down. All right, dividing by negative 2, so that involves dividing by a negative. So we're going to take our copy of the number line and we're going to flip it, because that's the negative portion of dividing. And then dividing by 2, that's going to compress everything down by 2. So all of these distances will become 2 times smaller. Since these distances are 2 times long, all we have to do is just make them 1 long. And that is just this number line right here, where all the distances from one number to the next are 1 tick instead of 2 ticks. So we've divided it by 2, and because of the flipping, we've divided it by negative 2. So let's see where everything lines up. So 4 lines up with negative 2, which means that 4 divided by negative 2 is negative 2. Right, so the 2 portion, that comes from us compressing the number line, and flipping from a positive to a negative comes from the flipping portion of dividing by the negative. Next up, negative 3 divided by negative 2. Negative 3 is right here. Where does that line up? That lines up with 1.5 by the looks of it. And since 3 divided by 2 is 1.5, yeah, that should be the numerical value. And because dividing by a negative involves a flipping, we go from a negative to a positive, so we get 1.5 as our answer. And lastly, we have negative 2 divided by negative 2. Negative 2 is right here, and that lines up with 1. So our answer should be 1. Another reason we know this is that any number divided by itself equals 1. All right, we're just breezing through these. Let's go on to number 3. So this one says, without using a number line, calculate the following. 10 divided by negative 2. All right, so we're not using a number line here. So what's 10 divided by negative 2? Well, we know that 10 divided by 2 is 5. And do you remember the rule for what a positive divided by a negative is? It's a negative. And if you think back to the number line, right, dividing by a negative, that's flipping from the positive into the negative or from the negative into the positive. So we get negative 5. Next up, we have negative 5 times 10. Well, what's 5 times 10? That's 50, right? But what's a negative times a positive, right? We have an uneven matching of negatives and positives, so we get negative 50. All right, negative 18 divided by negative 9. This purple pen's running out on me too here. What's 18 divided by 9? Well, how many times does 9 go into 18? It goes in twice, right? 9 plus 9 is 18. So we get 2. But is it going to be positive or negative? Well, we have a negative divided by a negative, so that means we're flipping from the negatives into the positives, so this will be a positive answer. And lastly, we have negative 4 times negative 0.5. Well, what's this going to be? Well, what's 4 times 0.5? 4 times 0.5. Okay, well, we're taking 0.5 and we're adding it to itself 4 times. So that's 0.5, 1, 1.5, 2, right? So 4 times 0.5 should be 2. Or if we want to think of 0.5 as like half, we're thinking like, what's half of 4? Well, it's 2, right? And is it going to be positive or negative? And similar to part C, we have a negative combined with a negative. So a negative times a negative is a positive. So our answer should be positive 2. And something to keep in mind with these is that when we're actually doing dividing and multiplying by positives and negatives, ideally we're just going to have the rules memorized, kind of like what we were doing in number 3, where we know that positives combined with negatives are negatives, negatives combined with negatives are positive, and so on and so forth. 3 is based on the idea that you've memorized those rules at this point, whereas 1 and 2 are kind of like the logic behind those rules, where we can actually visualize what kind of flipping is going on. All right, number 4. I'm using a blue pen this time because we've run out with the purple pen. All right, I have a rubber band that I'm watching in a mirror, and I stretch it to be 5 times as long as it started. From my perspective, what were the transformations applied to the rubber band? Okay, so first of all, we're watching the rubber band in a mirror. So if we're watching something in a mirror, do you remember what transformation that kind of referred to? That's right, that's like applying a negative, right? So we have a negative as our first transformation. And then we said we stretched it to be 5 times as long as it started. Well, what kind of models stretching something out by 5? It's multiplication by 5, right? So we've applied a negative and we've multiplied the number line that this rubber band supposedly lives on by 5. So a flip and a multiplication by 5. But what transformation do those correspond to? Corresponds to multiplying by negative 5, right? That's the double action of multiplying by a negative. So if we think about looking at us stretching a rubber band in the mirror, we're basically looking at us applying like timesing negative 5 to that rubber band. The negative being the reflection in the mirror, and the multiplying by 5 being the actual stretching occurring. All right, so that's kind of an interesting perspective you can think on like real world transformations. All right, number 5. This one's kind of interesting. I have 2 numbers. They both have the same amount of minus signs in front of them, but I don't know how many minus signs there are. So I have 2 numbers, right? Number 1 and number 2. and they have the same amount of minus signs in front of them, but you don't know how many minus signs there are. So there could be like 3 minus signs in front of them, or 4, or 5. We don't know, right? We have no clue how many minus signs are in front of them. All we know is that it's the same amount in front of them. So if I divide these two numbers, will the result be positive, negative, or do we not have enough information to find out? What do we know about having multiple minus signs in front of a number? Well, if it's two minus signs, let's say the number is 2, right? If we have two minus signs, that gives us a positive. If we have 3 minus signs, that gives us a negative. 4 minus signs, that gives us a positive. Again, remember, so we have an even number of minuses, we get a positive number. If we have an odd number of minus signs, that gives us a negative number. All right? But they have the same amount of minus signs. So that means either we have a positive divided by a positive, or we have a negative divided by a negative, right? Because we're dividing the two numbers. But if we have a positive divided by a positive, what does that give us? That gives us a positive number, right? Or what if we have a negative divided by a negative number? Well, what's a negative divided by a negative? That's also a positive. So regardless of how many minus signs are in front of these numbers, because they have the same amount, they are going to have the same sign, which means when we divide them, we're going to get a positive in either case. So the answer has to be positive. Now, there is a quick caveat with this question. I haven't specified what the numbers are. So we could technically say, okay, what if the numbers were 0, right? Well, negative 0, that's the same thing as 0, right? So in both these cases, the numbers would be 0. And as I've said in the past, and as I have yet to explain fully, we don't know what 0 divided by 0 equals. So it's not really a positive or a negative, and 0 itself isn't positive or negative either, right? So if we consider the case of 0, we actually don't have enough information to find out. So if we think of the logic where the numbers aren't 0, then it's positive, guaranteed. But if we actually consider the fact that it could be 0, then the real answer is that we actually don't have enough information. So it's a little bit of a trick question there, but it's important to cover kind of both of the logic. Now, if I wanted to rule out this we don't have enough information to find out, I would specify in the question, I have two numbers that aren't equal to 0. Right? And maybe that would be arguably a better question because this is a little bit tricky to think about. But as you go through with algebra, considering dividing by 0, that's a very common case that we have to consider. So I think it's important to bring up here. But in any case, I appreciate you stopping by to check out this video. Again, next video is going to be the checkpoint, so make sure that you do some review before taking a shot at that. And I really hope you do take an honest shot at it because it's very important to really work with the concepts and get comfortable with them in math so that you can move forward with a lot of confidence. Because that's a large part of what doing well in math is about. Not so much being smart and everything, it's about just having confidence in what you know because then you can apply it to problems way better. But that's going to do it for me today. Have a good one, stay groovy, and I'll see you in the next video.